Hi, this is David with EV World News. We're talking about electric vehicles, green energy, and the stock markets. Today, I've also got electrical engineer Mike Herzog with us, and he'll be joining us shortly. And I have a special guest today, Michael Marsden from California. How's your day going, Michael?
It's a little rainy up here in Northern California, but we like the rain. It helps with keep things green and helps the fish swim around.
Yeah, well, it's better than the 5 inches of snow I had to shovel yesterday. So,
Yeah.
living in Omaha. So, we're going to talk today about specifically about lithium extraction, but you got a whole lot of different minerals, and you do this in Southern California, right?
Correct. At the Salton Sea in
Yeah.
Imperial County. Yes.
Now, can you tell me what created the Salton Sea? Because I never really had noticed this. Like, I don't live in California. I mean, I've been there plenty of times, but it's not something I've ever visited. How did this Salton Sea thing come about in the first place?
Well, that's a great question. It's a long story. This last version of it, it's a low spot. It's 200 feet below sea level. So anytime things slosh around, it fills up with water and dries slowly, and it's become, it has been a dry lake bed. This last version was caused when they built the Hoover Dam in 1908. They diverted the water so they could build a dam, and they thought it was all going to go out to the Sea of Cortez, but Mother Nature, being in charge, said, "Well, no, we're going to send it over to what they call the New River, which is the one that connects up to the Salton Sea," and it filled up. It's 350 square miles of water, which is the largest body of water in California. Most people don't know that, but it's it's a big piece of it's a big water. And underneath it is the San Andreas Fault, the part where that's actually the start of the fault, and
Hmm.
that's why we're there. It's a subduction zone where the Pacific plate goes down underneath the North American plate and hits the hot magma, and it scrapes off all the old seabed, and it's like a big teapot down there that's boiling under high pressure, and all that material comes bubbling up to the top in the way of hot geothermal brines. It's not contained, so it doesn't become a volcano, but it's as hot as any volcano around. It's the source of all the minerals that we mine the brine for.
So now your organization has a method of extracting the all these things from brine. Can you talk about that a little bit?
Sure. Well, the brine is just simply salt water. Salt water is like sodium chloride is the salt everybody's used to. Well, there's also lithium chloride, which is what we pull out. It's another salt. There's a lot of metal salts. There's gold, silver, platinum, palladium. There's potassium. There's calcium. There's selenium. There's just a whole list of actually 20 elements that are on the critical elements list from the standpoint of the U.S. government. So what we do simply is, our organization, uh, to solve the problem about how to do this efficiently and profitably, and in the most ecologically friendly way. We decided about 5 years ago to start studying this, and we, myself and my associates, found all the engineers around the world that actually did various aspects of this in mining brine and extracting and refining and manufacturing the chemical products necessary for things like cathode for rechargeable batteries, lithium ion batteries. So after the research, we've come up with a system that does this in a vertically integrated way right on top of the wells that produce the brine. So, we have the ability to pull the brine up, which comes up by itself. It's under high pressure and high temperature. And the south part of the Salton Sea is the hot spot. That's where all the big companies are producing electricity, like Cal Energy or Control Thermal Resources or Energy Source and Ormat. Those are all using that same heat source. Although, their primary purpose is to make electricity. Our primary purpose is to extract valuable metals in a way that allows us to do it for the least amount of money and for the most ecological way. Because basically, we just have two 30-inch holes that go down to the brine, and the other one goes down to another part of the reservoir, which is vast. The reservoir is measured in hundreds of cubic kilometers.
Oh,
and
wow.
it's big. I mean, this was just recently. There was a paper that was published by Lawrence Livermore Labs in conjunction with the Department of Energy, and that's their number. So it's also the number from Mike McKibben at UC Riverside, who's been studying this thing for 40 years. But what we have is a vertically integrated extraction, refining, and manufacturing unit that has been designed by real engineers that have mud on their boots and hard hats, and not necessarily the lab guys, although we do love the lab guys. They help us out with things. But we're in the process starting to. We're going to be building our first unit here real soon. We have a number of buyers that want to buy these things, and uh, they're machines that extract metals and can produce chemical products at a very low price.
That's pretty fascinating. Now, how, when you say they're going down this 30-inch tube, how far down are they going?
It depends on uh, most of the geothermal guys go down like 4 to 6,000 feet. We go down a little deeper. We go down to the 9 to 12,000 foot level. We like
Wow,
to
that's
get
two
real
miles.
hot. We got to like to get real hot, hot and heavy down there. That's our favorite spot.
Wow. So 2 miles down. That's pretty amazing. Yeah, I mean, so use some kind of boring device to drill through the earth and drop a pipe down there.
Yeah, Baker Hughes has their mud motor. It's a motor that it operates the grinder, and it's operated hydraulically with the mud that's used in the drilling. So the mud is used to communicate with it as well as to power the drill heads. Otherwise, you have problems with temperature because they melt the working parts of the grinders.
Oh, wow. Yeah, so I see from, and I'm looking at a list here from one of your decks that you've got all these different lithium, sodium, potassium, rubidium, cesium, manganese, calcium. I mean, it's a huge list of different items. Now, obviously, the one that I'm most interested in, being in the EV space, is lithium. What kind of lithium production are you expecting out of this in terms of being able to create the battery producer could use to create batteries? Do
Well,
you
we
have
make
any idea how that pokes out?
Yeah, each of our we have a different approach to mining. Obviously, we're called green miners in my mind, and we have a modular system here that is kind of like a parallel processing system in computers, in that we have small units that are producing product for various purposes. In this case, making lithium sulfate or lithium carbonate or hydroxide for the cathode makers at the battery guys. They use that to make cathode for the rechargeable lithium ion batteries. We can do that to a spec sheet. For example, if a battery manufacturer has a specific need for low sodium or some other characteristic, by having small units, we can tailor to their spec sheet. Whereas if you go to the other philosophy of we want a big, massive 100,000 metric ton per year production unit, you're producing pretty much one thing for everybody. We'd rather go the other way in the small side and have lots of small production units so that we can be specific to the spec sheets of the manufacturers that use the product.
Wow. Yeah, I guess this is one of the things. So when I'm, you know, doing my podcast, and I also get a lot of, crazy feedback from people. It's like, oh yeah, for all those batteries, you got all these children that are being forced into slavery in some country and all this. And I hear all these stories all the time. And it's like, how much dirt you have to extract out of the ground to make that battery, and, what the cost is, and how long it takes to overcome the toxic mining. And so you mentioned you use green mining t can you tell me what's going on there, why you would call it green?
We call it green because Oxford University calls it green. They
Okay.
published a paper recently calling it green mining. Uh, Specifically, we don't really keep the material on the surface. We take it out of the ground, comes out hot and heavy. We sort
Mhm.
through all the elements that we want to extract for commercially valuable, and then we put the rest back in the ground. So at the top, there's really nothing laying around that we are not selling,
Oh, okay.
and it's done
So,
in real time, within days.
and how disruptive is this to the environment around where you're mining?
We're growing our vegetable garden next to it, so I mean, you can. We're not worried about it. It's really kind of a closed system. You don't have really anything that's toxic in the whole process. I mean, we by being brine miners and refiners and manufacturers, we really don't use any solvents. We just use their salts, bases, and acids in order to do our stuff. And most of everything that we use, other than we do have to buy some sulfur products, we have on site. We don't really buy anything.
So let's do this. Let's go a little bit through. You sent me a deck, and we can go through some of these slides. Give me a second
Sure.
here.
Yeah.
So here, this is the very first one. We have a problem with domestic supply. Do you want to go ahead and address this?
Yeah. The United States has to import all of the materials, or almost all the materials they use in any uh, most anything else. I mean, manufacturing from other places like China, which is difficult sometimes politically. It's also expensive from the standpoint of you have to pay, and it makes the United States vulnerable for other countries to control our ability, especially when it comes to defense projects. So,
Well, right now the government is incentivizing through EV sales that the batteries have to have components made a certain percentage that are either from the United States or from one of our preferred trade partners. And it
yes,
specifically is excluding China. And so certain cars, because the big car or battery manufacturer in the world is cattle, which is out of China, and they're excluded. And so it makes it harder to get the EV subsidies. So right now, the finished lithium ion batteries were showing, this was from 2021. I'm sure that number has improved a little bit in the past 2 years, but it was 4.7% here in the US. So that's it's actually surprising that that high of a percentage was done 2 years ago. Um, let's go on to the next one. So here you're talking about the broken link in the domestic supply chain. You want to talk about that just a little bit?
yeah. This is basically what we're talking about doing. We're brine miners, if you will. In the brining sites, if you look at this chart on the left hand side, that number has actually gone down since then. There's only one manufacturer of lithium products right now in the United States that's actually producing, and that is U.S. Magnesium in Salt Lake City. Everybody else is shut down. It's Silver Peak, which was down mining the lithium clays and in Southern California and Nevada. They were purchased, and they're in the process of switching over systems, so they're not producing anything. So literally, the published paper that came out from the Department of Energy about lithium production from the U.S. Geological Survey people said they couldn't tell us what the production was because it was proprietary, because there was only one producer. So
Wow.
that's less. It's gone down from that chart.
That's really sad to think about. And I hear news all the time that's like big lithium discovery in Nevada or big lithium discovery in Utah. But it's one of these things. It takes money to be pushed at it to be able to get things going and extracting, right? And
Well, yes,
that's
there's
a big part of it.
the problem is that a lot of people like to talk about raising money, but not a lot of people like to talk about producing products. And some of the people out there are more interested in producing uh, information, more interested in selling stock, more interested in doing all these other things than Yet they have been and some of them been in business for a long time, and they have not produced any product. And it's not because the technology is not there. I mean, we're using old technology, and we're very confident about it. And a lot of people went to the other direction. They wanted to use new technology, so they went out and they hired companies that had the latest patent for membrane separation or the latest patent for direct lithium extraction systems and things. And uh, after spending literally billions of dollars, they found out that those techniques couldn't handle the hot and heavy brines that were in the Salton Sea area. And so uh, both those big companies down in that area had let those people go, and now they're off in other directions. Our engineers came from places where they're already doing this. For example, Ganfeng is a big company down in China that makes lithium a cathode product from ore spodumene they get from Australia. And what they do is they have to digest the rock, and it comes down to them going to an absorbent, and we just use the same absorbent they use. And yes, it's not as efficient, but it works. And so the fact that it works is all I care about. I'll double my volume if I need more. It's, again, bragging that you get 99% of all the lithium is not a big deal to me. I mean, I'd rather just get 90% and be able to have it reliable and actually produce product.
Yeah, and not have the machines break down from the heat.
That's another thing. There's a lot of people who look at the various processes that we do. If you get involved with the actual way we do things, you'll see that we go to some real basic things rather than to go to the high-tech products. Like, for example, we don't have a crystallizer. We concentrate the lithium sulfate for example, to a point where it crystallizes all by itself. All you have to do is lay it out on a concrete floor and let it get warm in the sunshine, and it crystallizes up real quick. That's a lot cheaper than buying a $10 million crystallizer. So yeah, basic stuff.
Well, when you're in that business, I guess, and you've had experience and you see why one thing works and one doesn't, that makes a big difference. Oh, let's see what we got here. Do you want to talk about this one? De-risk and plan?
The whole point of our study started 5 years ago was to de-risk the process of being able to produce these metals, not only lithium, but others, in a way that is the least risk to the investors. I mean, one of the biggest problems about mining is there's such people say, well, I'm going to produce something in $1 billion. And we said, there's got to be a better way. That's where we decided to go to small production units because they have lower capex, and to be able to use existing wells that are known, either that are not being used currently or that have been abandoned, because the regulatory time is much shorter on reconditioning an old well than it is to build a new one. And then also, you have the advantage on the old wells that you have all the information as public record. So you could go down and say, well, we had Phillips Petroleum dug this hole in 1980. What was down there? Well, you go down to CalGem and look it up. It just says it right there. This is what the chemical report says, and this is what the well log said on the way down. And so, if you got to go back and go to that old hole, even though it's like 30 or 40 years old, you know what you're getting into. So that takes risk out. And also, we wanted to be able to build smaller units, in modular units, in a parallel, so that we'd be able to get a quicker payback period for the investors, because a lot of investors don't want to hang out for 20 years or 10 years. A lot of them want to see their money back in a shorter period of time. So going to smaller units.
So is a lot of this process able to utilize the old work that was done by the oil drilling companies?
Yes.
So you're able to use the same holes and all that, so it saves on boring and all of that.
You have to recondition them. I mean, each of our projects has about $4 million in the budget for reconditioning the old well, because something's always wrong with them. But the
I
point
understand.
is, we have to recondition it, but the risk is taken out because we know it's down there. It's not a wildcat well. They were looking for oil and found brine. That's what we.
That answers a big question because I was sitting wondering, it's like, wow, that's pretty speculative drilling 2 miles into the earth looking for these materials when in reality somebody had been down there 40 years ago and they'd already done a report on this and just nobody realized there was a need for it till the last few years.
Yes.
That's pretty cool. Well, I'm glad to see that coming back. Now, in your situation, you mentioned this create a quick 3 to 4 year payback period for production for investors. So generally, from start getting one of these wells started and mining, what is the length of time it takes for that to actually start extracting from day one when you have investment in one of these mining machines?
Our plan is 24 months. We could possibly be as early as 18,
Mhm.
so that we can have cash flow right away. If you look at the EBITDA on it, we're looking at 65 to 70%. If you want to look at the dollars, they're on a regular production unit that's producing 1,500 to 2,000 tons a year. We expect that to be $30 to $40 million a year return on a capex of 60.
Right. That's an interesting process. Now, of that 18 months, is most of that in the construction of the mining machine, or these already
Yes.
exist?
No, we build the machines. We have our partner, which we recently announced, is Hargrove down in Atlanta. They're the process engineering company that builds these types of devices. And we're in the middle of talks with them to produce these units, both in Atlanta and here. They're designed to be shippable, so all the parts have to fit into 40-foot containers. And we have people in Africa. We just met with, in fact, right before this meeting, we were having a meeting with a number of African investors that want to have these devices there on their geothermal hotspots in Africa. So we need to put it in a container. So all our stuff
Right.
is designed to fit in a container.
Well, that's pretty cool. Um, let's see. So a production facility costs about $60 million to set up, and you've identified 30 plus locations for these.
In Salton Sea. Yeah, there's others. There's some nice ones up by Salt Lake, Great Salt Lake. There's others that are in the old volcano area around Yellowstone that we like. Each one has different metals in it.
Well, that's pretty cool. Let's see here. Um,
Yeah, there's Hargrove letter. That's the new
where is this lab at?
one. That's a lab that we started our work at. That's down in Arizona at a refiner that does mostly uh, silver and gold. Although we use other labs as well. We just had to have a lab picture. This is one of the labs that we have control over. We use. We also work with Lawrence Livermore Lab. That letter that was above there, we're currently working with them. One more describe. Yeah,
There we go.
there it is. Yeah, we've been working with Lawrence Livermore Labs for quite a while. They like us because our engineering group are actually people who are doing it rather than just thinking about it. And so we have a project, a grant. This is a grant application we just submitted a couple of weeks ago for a Department of Energy grant to be our next generation of absorbent. We want to make our absorbent not only better, but also more versatile. This particular one is to make it last longer so that we have less cost. Pretty boring, but it's,
No, no,
but
I
Livermore
understand.
Labs likes us.
One of my concerns is throughout this whole process is making it so that electric vehicles are easier for people to understand. There's so many misconceptions about them. And a lot of this comes down to stuff related to the batteries. I hear all these stories and all these terrible things that are people, like I said, well, I should ask you, how many children are you going to use as slave labor there in Southern California?
it's the it's the area that has the highest unemployment rate in California and also the highest poverty rate. So we're hiring people who really want a job.
Hold on. So let me rephrase that in a more entrapping fashion. When did you decide to stop using child slave labor? No.
When I was a child.
Oh, yeah, because it's just interesting to see all of the things I get about how, all these horrific things are happening. And the funny thing is, in the extraction of oil, they use a lot of these same precious metals in making the drilling equipment and things like that. And it's really quite interesting. Although, lithium obviously has had huge demand in the batteries. And man, yeah, I've had people on. We were looking at batteries in some Peterbilt trucks. They have a 565 kilowatt hour battery, and
Yeah.
that's like six, Tesla batteries for cars, and it's already a problem, because Toyota's like, we like hybrids because we can make 10 hybrids for every EV, and Toyota makes so many cars they have a hard time wrapping their heads around having enough lithium if they were ever to convert all car sales they do worldwide to just EV because it's just such a staggering amount of batteries that would be needed. And the world's getting there. The world's getting there, but it's one step at a time, right? And I like what what you're doing here. Let's see here. What might
The
be
battery technology is improving, and there's a lot of opportunity for improvement. Like you mentioned, the weight and also the cost, and also the collateral damage in case they start catching on fire. I think that one of the reasons we went to making small production units is to service the small lithium industry, the original one that makes glass and ceramics and lubricants and cement, quick drying cement, those sort of things. We're really aiming for that market because I don't believe that the lithium ion battery market will be the one that will be the prevailing way in the future. Although we'll sell to cathode makers, it's not a problem. And anybody who wants to buy our product will sell to them. But the reason we're building small units is to be specific towards individual manufacturers of other products.
I want to talk about this a little bit because you've got these North American gigafactories. Do you want to discuss this a little bit and
Yeah.
explain what
Mm-hmm.
a gigafactory is, and then talk about what these companies represent here?
Well, a gigafactory basically starts with gigawatts, so they're big, they're billion watt plants, so they expect to build a lot of batteries. This is in response to the demand for EV batteries, and it's not only just cars. I think the biggest demand will end up being in utilities because these are nice ways to balance long distance grid circuits. So you can have instantaneous energy with large megawatt type batteries that are there and available in the instant. But vehicles are also part of it. I don't think the vehicles will ever be as big a demand as the grid. Actually, I think that these gigafactories will make a lot of batteries for things other than electric vehicles. But these are the plans. These are companies that are planning on producing batteries, lithium ion batteries, and they're all at various stages of production, and they all have the same problem, and that is supply,
So,
materials.
something that's kind of interesting in the EV space is a lot of people they always hear about electric vehicle batteries failing and having to be replaced. But in the EV space, a battery is considered to be failing when it hits 80%.
Right?
Okay, so or of if it only holds 80% of what it held initially, then it's considered to be failing. Well, those end up going to long-term energy storage. They're simply repurposed for
Yeah.
another 15, 20 years. A lot of people think that they're being thrown in the trash or that like, if you
Uh,
can't recycle them, they're told they're too hard to recycle and all this. And the truth is those batteries are going to be used for 20 plus years before they ever look at being even recycled. And so it's interesting kind of see this. I've not even heard of a lot of these companies on here you got some of the obvious ones like Tesla and Lion and GM. These other ones, most of them I've never even heard of, and they're all developing battery tech.
Yes.
It's amazing.
The recycling guys make after they're done digesting all the parts, they end up making lithium sulfate, which is why lithium sulfate's our primary product. In that it's the easiest one to use to make cathode, and that's also a market that's already been established by the recyclers.
Nice, nice, nice. Let's see what else we got here. Current state of the lithium industry. You want to talk about this a little bit?
Well, the current state is that they have a supply problem. It's up and down right now. There's a lot of supply because China decided to do its normal thing about dumping supply and killing off all of the people who are manufacturing products in competition with them. They do that
Mhm.
pretty much on all the commodities. They did it on the rare earths, et cetera. But now the prices for lithium carbonate per ton is down in the 20,000 range per ton, whereas it was almost 70,000 this time last year. And so these wide fluctuations make it difficult for people who produce these elements and make these products to stay in business because they go out and make a big capital expenditure, then China dumps the market, and next thing you know, they can't afford to sell their product and they can't afford to make their payments, and so China stays dominant that way. So the future of the lithium industry, I think, is that it's going to be going back to basics, like for the glass and ceramic and cement and lubricants and medicines and those sort of things. Lithium will always have a place in a market because it's the metal that weighs less than any other metal. It's the least. It's number three on the periodic chart, and its properties will always be in demand because of that. But the current state is that the lithium industry is kind of mixed. I think the price is down because the Chinese have been dumping in. It'll go up afterwards after they knock everybody out of business, and then it'll
Right.
go back to them making all the money. Well, I think that America needs to protect the miners and protect the people who develop these things because it's hard to do. I mean, it's hard to raise money. It's hard to have a project that takes years, let alone some of them decades.
Right.
So America needs to protect its own territory, and it needs to stop just bowing to Chinese commodity people.
Let's see what else we got here. We talked about this a little bit. Oh, I think we reached the bottom of the slide. And here is your website, highpowersaltonsea.com.
That's correct.
Nice. And let's see. Is there anything you'd like to add that we didn't discuss today?
Uh, uh, Not really, other than I think it's important for people to know that there is such a thing as green mining. And this is not only just for lithium, but for other elements as well. I think green mining needs to be recognized as not open pit mining, not just giant evaporation ponds that cover, millions of acres. This is actually something that can be used worldwide. Mining brine is, I think, the future of mining. I think it should be given an advantage because people need to know that there are types of mining that are bad for the environment, that pollute the lakes and streams, that have all these other problems. Brine mining does not. We're not taking anything and keeping it on top. We're putting it all back in the ground. And the only thing we keep are the things that we can sell. And if we want to go back later, we'll go back and get the stuff we put back in the ground. It's
Right.
one big, it's one big saltwater pool down there. So
It's funny how much of an opinion people have that when they think of mining, they do think of the open pit strip mining. That's what
right,
everybody
right,
generally thinks
right,
about, and just destroying, leaving like this horrible moonscape and all this, and that's clearly not what you're doing at all.
right. Well,
And
that's the message I'd like to get out. Is the final word? The green mining is here. We need to support it. The investors need to support it, and the people need to recognize it as the answer, and to use their power to purchase to influence that decision. Go with green mining.
All right. Well, I don't have any other questions for you today, Michael. I really do appreciate you coming on the show today. And for me, this was interesting, and I've seen lots of people watching as we've been live. And so I know there's been some interest in this. And I'm going to go ahead and end the stream, but people, please feel free to leave comments and let us know if there's anything you might like me to follow up with Michael. And please hit the like button so this will get shown to more people.